I'm breathing in.
Hello, today we are doing regressions with Professor Maxwell Lohman. I'll be teaching on how to take a linear, quadratic, or cubic regression on a TI-N-SPAR calculator. It is a good way in making mathematical models. Sometimes you'll be given a chart and you might need to determine the equation from that chart information. In that case, you can perform a quadratic, linear, or cubic regression. It's a good way of plotting an accurate line of data and plotting the trend. Your best fit line slope will appear as the A value, and the best fit line's y-intercept will appear as the B value. Your best fit parabola's equation, y equals ax squared plus bx plus c, the A, B, and C values will appear. For a cubic regression, y equals ax thirds plus bx squared plus cx plus d, the A, B, C, and D values will appear. For all of these regressions, the R-square represents the coefficient of correlation. It tells you how strong the correlation is. The closer R-square is to 1, the more accurate the graph is. The closer R-square is to 0, the more inaccurate the graph is. Hello, today the first thing we'll be doing today is making a linear regression on our calculator, the TI-N-SPAR CX-CAS calculator. I just think it's a marvelous calculator. Just look at all these buttons. So the first thing we'll be doing is turning on the calculator. Next, you'll be going to the bottom of the calculator and you'll be going to Add List in Spreadsheet to New Document. So today, the linear regression is going to be the US population growth from 1920 to 2010. So once you're on the list and spreadsheet, you'll be going to top left where it says A. There, you'll be putting in X. Then you'll be going to B, and you'll be typing in a Y. So the next thing we'll do is type in the years. So if you go to the first column under X, you'll be typing in 1920. Next, you press Enter, so you can type in the next decade. So now I'll be typing in 1930, 1940, 1950. Oh, my bad. 1940, 1950, 1960, 1970. 1980, 1990, 2000, and finally 2010. So now I have typed in all the years for the US population growth. So after that, we'll be scrolled down to B1. Here we'll be typing in the US population. In 1920, the US population was 106,021,000 and 568. So now we'll press Enter, and now we're going to press in the US population for 1930, which is 123,202,660. So I'll be coming back when I'm done clicking these in. Hello, I am back, and I've finished plugging in the years in the US population between 1920 and 2010. So after you're done plugging in the numbers, you'll be going to Statistics, Start Calculations, and Linear Regression. So when you get here, you're going to put an X into the X list, and a Y to the Y list. So after that, you'll be going to clicking OK, and here you'll be having it. So here you have your M value, you have your square, which is y equals mx plus b, you have your b, which is your y-intercept, and r squared, which is 0.98, which I think is pretty accurate. So after that, you go to, and after that I've written out the equation. Y equals 2.28x minus 4,273.78. So now we're going to make our linear regression and we're going to graph it out. So after that, you take your mouse, and you're going to unsaved. From there, you're going to insert, and you're going to data and statistics. From here, you're going to move your arrow and click add variable, and you're going to go to the y in the y column. Then you're going to put an x. You're going to put an x in the x column. So here you have all your points lined out. So now you want to actually graph out your best fit line. So now you're going to menu, analyze, regression, and show linear mx plus b. Here now you have your you have your best fit line. That's pretty close, especially with the r squared equaling 0.98. So after this, when I get back, we're going to work on a quadratic regression equation. So hold on for a moment and I'll be back. See you, audience. Hello audience, I am back, and now we're going to get ready for the quadratic regression for the US population between 1820 and 1920. As you can see here, I have prepared all my information, and here's the source of my information. So let's review what we did last time. So last time we worked on a linear regression of the US population from 1920 to 2010 and made a regression and a best fit line. As you can see here, here's the best fit line, and here's the scattered line. So here's our A value, B value, and R square. So now let's go on to the quadratic regression. So here I have made a clean screen. Just look how beautiful this TIN spire is. So now we're going to put in the X again as we did earlier, and we're going to put in the Y again. So in the X we're going to put in the decades from 1820 to 1920, and the Y we're putting in the years. So I'll be back once I'm done putting in these information. Hello audience, I am back, and I have typed in all my numbers. So now, after you typed in all your numbers, you're going to press menu, then you're going to go to insert, never mind. You're going to menu, statistics, then you're going to start calculations. Instead of going to linear regression of last time, now you're going to quadratic regression. So here you go to X list, you type in, you put in the X, you go to Y list, and you put in the Y again, just like last time. After that, you're pretty much set, and you press OK. So now you have your quadratic regression. So here you have the equation of the quadratic regression, ax squared plus bx plus c. Here you have your A value of 7,485.32 x squared. You have your B value and you have your C value. Here the R squared is 0.999. That is pretty accurate. So here, with your A, B, and C values, you get your final equation of 7,485.32 x squared minus 27,018,464x plus 24,388,860,299. So that is a crazy number. So after that, you take your mouse and you go to unsave just like last time. Now you're going to go to insert, day and statistics, and now you go add in the Y just like last time, and you're going to add in the X. So now after that you're going to menu, analyze, regression, and show quadratic regression. So here's your best fit line right there. You see, as you can see here, is almost line in line. It's pretty accurate. And now you have made the mathematical model for the quadratic regression of the US population from 1820 to 1920. And when I get back, we're going to work on the cubic regression, which is an even bigger exponential, a steeper exponential than the quadratic regression. So till then, see ya. Hello audience, I'm now back, and now we're going to start working on the cubic regression. We're going to do it on the number of transistors in computer processors over many years, from 1997 to 2007. So here's the chart I'm going to use, and the circled information are going to be the processors with the transistor counts that I'm going to use. So now we're going to go back to our calculators again. So in the A column, just like we've done the last two times, we're going to type in an X. In the B column, we're going to type in a Y. So now we're going to type in for the X column the year, and for the Y column the number of transistors. So I'll be back with all these numbers filled out. Like we reviewed from last time, you type in the number and then you press enter, and then you type in another number and you press enter. So, bye. Hello, I'm back and I've typed in all the numbers for the number of transistors in graphics processors from 1997 to 2007. If you really think about it, the number of transistors in the graphics processor is just mind-blowing. So now, we're going to continue by going to Menu, Statistics, Start Calculations, and this time going to Cubic Regression. So you go for the X list, just like the last two times, you go to X. For the Y list, you're going to go to Y. And now you go press OK. And now here you have it. Here that shows the equation of ax third plus bx squared plus cx plus d. You have the a value, the b value, the c value, the d value, and the r squared of 0.999. So now you know that equation is pretty accurate. This calculator is just amazing of how it can do all these things. So now you're going to go to make the graph. You're going to take your mouse, you're going to click on unsaved just like last time. Oh, my bad. You're going to go to unsaved. You're going to go to insert, data and statistics. You're going to put the Y in the Y column and the X in the X column. So here you have all your points laid out. So now you're going to go to Menu, Analyze, and now you're going to go to Regression. And now you're going to show cubic. So now you have your best fit line. Oh, that lines up with all the points, so now that shows that it works. And if just look how this best fit cubic regression lines up with all the points. So so you can see the equation here, which I forgot to mention earlier, is 1,190,393 x thirds minus 7,138,728,918 x square plus 14,270,204,571,511 x minus 9.508. That's a crazy equation with the r squared of 0.99. So now you know it's accurate. So now, so we're pretty much done. So I'm going to give you an overview of what we've accomplished since I started this video. So here I did a linear regression of the U.S. population. I'm not from 1920 to 2010, and here's the data I used, and here's the equation and to graph as a whole. Here's the quadratic regression of the US population from 1820 to 1920. That's what I did second. Here's the equation and the graph written out as a whole. And here's my cubic regression of the number of transistors in the GPU from 1997 to 2007. And now here you can see the equation as a whole and how it looks out completely. So I'm done for today. I hope you enjoyed this, and I hope you've gained an interest in math and learned a lot. And thank you very much for watching. I hope to see you next time. Bye. P.S. The fact that the TI N-SPAR CXCAS calculator shows how much of a better calculator it is than the TI-84 calculator. It's just amazing.